All right, let's dive right into this explainer and learn how we can actually teach a computer to make decisions just like we do. I mean, from the apps on your phone to self-driving cars, it literally all starts right here. Welcome to the journey of decision-making using Python conditional statements.
You know, the whole core philosophy of coding boils down to just 3 simple steps. Think, decide, and act. Think about it. Every single day you wake up, look at the weather, and decide what to wear. You think about the temperature. You decide if you need a jacket, and you act by putting one on. Computers do exactly the same thing, but we just have to give them the precise mathematical instructions on how to process those thoughts.
So, before we actually look at any code, we need to define our main tool for today, and that is conditional statements. The crucial point here is that these are tools that allow you to make decisions in your code by executing blocks of code only if a specific condition is true. Think of it like a gateway that tells the computer, hey, if this specific scenario is happening, I want you to do this specific action. This right here is our complete roadmap for today. It's a really beautiful cheat sheet that takes us all the way from simple, everyday checks right down to complex, one-line developer magic. We're going to unpack this entire thing together and really build up your coding tool belt. Here's our agenda. We're going to follow this complexity escalation, starting with the simple if statement, adding the else condition, tackling multiple choices with if, nesting ifs within ifs, and capping it off with some one-line magic using ternary operators. All right, section 1, the simple if statement. Let's start with our very first building block, the foundational if statement. Basically, the if statement executes a block of code only if a condition is mathematically true. Imagine you're checking someone's age. Our code says, if age is greater than or equal to 18. If their age actually is 18 or older, that statement evaluates to true, and the code acts, printing the word adult. It's a super simple, direct path. You start, check the condition, if true, act, and then end. Simple and easy.
Moving right along to section 2, adding the else condition.
But think about it. What happens when our simple observation fails? In that last example, absolutely everything hinged on this crucial threshold number, 18. If you are 18 or older, great, the code runs. But what if the person is 17? Under our previous rule, the computer just stops and does nothing at all.
Well, that's exactly where if-else comes in. Now we're giving the computer a fallback plan. If they aren't 18 or older, the false flow kicks in. The logic states, execute one block of code if true, otherwise execute a different fallback block. So if the age check is false, it prints minor instead. The logic flowchart just splits into 2 definitive paths. No matter what happens, the computer now knows exactly what to do.
Let's step it up to our next tool and see how this builds from a simple 2-choice binary decision, like an adult versus a minor, into something that can handle much more multi-layered scenarios, like assigning school grades of A, B, or C. Because, let's face it, life isn't always just 2 choices. Which brings us to section 3, multiple choices with if-elif. Now, what's really fascinating here is how this code flows down like a waterfall. It checks one threshold after another until it finds a match. Imagine a student's marks are 85. The computer first asks if marks are greater than or equal to 90. That's false, so it totally skips the A. Then it moves to the next option, the elif, which is just short for else if. It asks, well, are the marks greater than or equal to 75? Since 85 is greater than 75, boom, that's true. It prints B and totally ignores the rest. And of course, if none were true, our final else fallback would just step in and print C. This sequential check-in is literally perfect for things like school grade systems. Anytime you have a tiered system, think tax brackets or game difficulty levels. This kind of cascading structure is absolutely what you need.
But let's push a little deeper, shall we? How do we handle conditions that depend entirely on other conditions? Like a scenario where passing one test just leads you directly to another test.
That is exactly what section 4 is all about. Nesting ifs within ifs. This is quite literally a check inside another check. A nested if is just an if statement placed neatly inside another if statement. Let's look at narrowing down a 25-year-old as a working adult. First, we hit the outer gateway. Is the age greater than 18? That is true. But before we get an answer, we hit an inner gateway. Is the age less than 60? That is also true. Only because both conditions are true, the computer prints working adult. If you fail either of those checks, the computer does nothing. You have to pass both gateways to reach the core action. And finally, section 5.
one-line magic with ternary operators.
Okay, now for the ultimate cheat code. The ternary operator is an incredibly short and sweet way to write an entire if-else statement in one single line. Because, let's be honest with ourselves, developers love efficiency, which is really just a fancy word for being delightfully lazy. Instead of stacking multiple lines of code to pass or fail a student with 55 marks, we can actually condense the entire logic horizontally. Result equals pass if marks are greater than or equal to 40, else fail. Seriously, just set your result to pass if the marks are 40 or above, otherwise fail. It is truly one-line magic. For developers who want their code to be incredibly clean, highly readable, and perfectly efficient, this little trick is an absolute game changer.
So here is your complete decision-making toolkit, mapping every single statement type we've learned to its exact real-world use case. You've got the simple if for a single true condition, if-else for when you need a clear fallback plan, if-elif-else for multiple cascading choices, nested if for those complex conditions inside conditions, and of course, the ternary operator for those beautifully short one-liners.
As we wrap up this explainer, I really want you to remember the enthusiastic encouragement from our source material. Coding is really just translating human logic into simple steps that a machine can actually follow. Just remember the core logic flow: start, check for true or false, take action, and end. Think, decide, act. That's coding, and you can absolutely do it.
Take these building blocks right into your own projects. Work through the logic step by step. Code smart, code simple, and code awesome. The power to teach a machine how to think is now securely in your hands. So I'll leave you with this. Now that you know how to make a computer decide, what future will you decide to build next?